Okay, good evening. Okay, so far in the class, in the English medium class, we have mainly silence. Okay. That is okay. So far in the English medium class, we have mainly worked with 4 units. So what we have done so far is we started with silence. We started with the silence. We started with basic mathematical concepts. And I told you this basic mathematical concepts is not a unit. It is where we discuss about some of the simplifications and some of these expansions and root simplifications that we will be needing for A levels. So simply those kind of simplifications you didn't have for your O levels, but for A levels you need these type of simplifications. So that's why we did these basic mathematical concepts and we covered those simplifications and all these expansions. For example, I'll give you like two examples. In O levels you didn't know the expansion of A cube plus B cube. For O levels you didn't know the expansion of A cube plus B cube. So under this category, we learned about the expansion of those A cube plus B cube. So that is just one example. And for O levels, you only work with simultaneous equations with two variables. Simultaneous equations with two variables. But for A levels, we will be working with simultaneous equations with three variables and even sometimes four variables. So in this category, we got the experience of working with three variables, a simultaneous system, simultaneous equation system with three variables. And then so far, what is the main lesson that we have done is this lesson polynomials. I'll tell you what is the reason that why I consider this as the main reason. Because after completing these basic mathematical concepts, I directly started polynomials to give you a confidence like by doing these A-level questions. Because basic mathematical concepts, you don't have like A-level questions in mathematical concepts. But we covered this lesson polynomials, and in these polynomials, we had A-level questions. So that is the reason I straight away started it after basic mathematical concepts, because when we do these A-level questions, you have this confidence and you have this boost that you can do these A-level questions. Because A-level is standard that you are getting. If you are capable to do those questions, you get a confidence about this A-level exam and about the subject. So that's why I started polynomials. And then we did a small unit called numbers. So this is the first unit of the syllabus. So what is the first unit of the syllabus? It's numbers. And then last week we finished inequalities. We finished inequalities. So both these numbers and inequalities, if we talk about numbers and inequalities, there won't be a direct question from inequalities for your A-level paper. Like in your A-level paper, you don't have a direct question from inequalities. But the knowledge of inequalities will be required in few lessons like quadratic equations and then in series and some of the parts of equilibrium will be requiring the knowledge of inequalities. So even though you don't get a direct question from inequalities, the knowledge is so important. And even when we are doing functions will be the next lesson we are starting. We know we should have the knowledge of inequalities. And when we talk about these lesson numbers, so that is an area, especially when we have to convert recurring decimals into fractions. So this is a thing that I did this only because that exists in the syllabus. But even for A-level exam, you don't have these questions from numbers. These recurring decimals, you don't have questions from recurring decimals to A-levels. Again, A-levels are making prashna nahi. Even for any other unit, you won't have questions from this one. But there are few things that we need to know about what are real numbers, what are integers, what are rational numbers. We need to know about them. So we got that knowledge from numbers. So since there are a few newcomers, that's why I just brief them what we have done so far. So today we'll be starting with this lesson, the new lesson. It's partial fractions. It's partial fractions. So the knowledge of partial fractions is important throughout combined maths because we need the knowledge of partial fractions in lessons like integration and series. Because I have seen students even in grade 13, after we do integration, when I give an integration question, they find hard to complete the question, not because that they don't know integration, only because they don't know how they don't have this knowledge of partial fractions. So that is the main reason. So that's why this is an important lesson. Not only that you will be getting directly questions for exams, and for few other lessons like series and integration, you need the knowledge of partial fractions. So any student who is a newcomer today, you can easily start from this lesson, and I'll make sure that you will understand everything that we explained today. But let's, after the class, let's talk how we can cover these areas. So I'll talk about that after the class. I'll make sure that if you focus properly and if you like listen properly, you can easily understand the entire lesson that we will be doing today, partial fractions. Clear? Okay, write the main topic, partial fractions. Write the main topic, partial fractions. Partial fractions, the main topic, partial fractions. Okay. Silence, 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 partial fractions. Okay. Okay, so write the main topic, it's partial fractions. Silence, silence. Main topic, partial fractions. Okay, now listen, focus. So let's talk what are partial fractions. So if I ask you to add these two, don't make me come and get you. Okay, so I'll do a example. If I ask you to add 1 over a plus 1 over b, okay, now listen, you can simply get the answer if you add these two by taking the common denominator. You get ab as the common denominator, and this is a plus b. No? So when you add these two, you get a plus b over ab, which means this a plus b over ab, this is equal to 1 over a plus 1 over b. And now it is clear, like when we add these two, we are getting a plus b over ab, which means this a plus b over ab is equal to 1 over a and 1 over b. Okay, so when we break down a particular fraction, to the initial fractions that the original fraction was made of. So what did I mention? You know, when we add these two, when we add 1 over a and 1 over b, I'm getting this answer. No? Which means a plus b over ab is made of 1 over a plus 1 over b. So when we break down or when we split a fraction or a fractional expression to the initial fractions that it was made of, when we break down or when we split a fractional expression to the initial fractions that it was made of, we consider these fractions as partial fractions. We consider these fractions as partial fractions. So what are partial fractions? So this is the fractional expression. So when you break down this fractional expression into the initial fractions that it was made of, we consider, or these are named as partial fractions. So the name that we give for these ones are partial fractions. So if I consider a numerical value, I know that 1 over 2 plus 1 over 3 is equal to, if you take 6 as the common denominator, it's 2 plus 3, which gives you 5 over 6. Which means 5 over 6 is equal to 1 over 2 plus 1 over 3. Here it is clear. I have considered, I have split this 5 over 6 into two initial fractions that it was made of. Then these are named as partial fractions. So what is the name that we give for these one? It's partial fractions. Okay, it's partial fractions. But the thing is, normally, okay, now listen. Normally, when we are working with partial fractions, we are not considering these type of fractions. Again, partial fractions, අපි මේ වගේ ඒවා consider කරන්නේ නැහැ. We won't consider about partial fractions in this way. Numerical fractions, we don't consider. So I'll take an example. If I ask you to add 2 over x plus 1 over x plus 1, you can take the common denominator and you will tell me that the answer is 2 times x plus 1 plus x. So when you simplify this, you get 2x plus x is 3x plus 2 divided by x into x plus 1. So that is clear. Okay, now you know that 3x plus 2 over x times x plus 1 is equal to 2 over x plus 1 over x plus 1. So this fractional expression has been splitted into two fractions, has been broken down into two fractions, or we can use even has been decomposed into two fractions. So these are the partial fractions of this fractional expression. So these are the partial fractions. This and this are the two partial fractions. So there may be 3, 4, any number of partial fractions can be there. Okay, so let's be simple and see what are partial fractions. When I break down a fractional expression, or when I split, or when I decompose a fractional expression to the original fractions that it was made of, these fractions, those original fractions are considered as partial fractions. So these are partial fractions. Okay. Okay, so before learning about partial fractions, there is one thing that we have to learn. Write in this way, using a black pen, write note, and using a red pen, write rational function. Using a black pen, write note, and using a red pen, write rational function. Rational function. Okay, so let's see what a rational rational function. Yeah, okay, rational function. So what are rational numbers? So before talking about rational functions, let's see what is a rational number. Tell me, what is a rational number? What is a rational number? We did it for not on the numbers. When we were doing basic mathematical concepts, we had rational numbers. No, what are rational numbers? Can't remember. What are real numbers? What are real numbers? When we square a selected number, if it is positive or can be 0, we consider those numbers are real numbers. So what is the definition of a real number? When we select a number and when we square that number, if I am getting a positive value, we consider that is a real number. Which means if we get a negative value, that is a imaginary number, which is not a real number. So anyone who can remember what is a rational number? No one. So what is a rational number? If we can express a number as a ratio of two integers. If we can express a number as a ratio of two integers, we call them as rational numbers. So when you take example 1 over 8, 1 is an integer, 8 is an integer, so 1 over 8 is a rational number. If I consider 3, 3 can be written as 3 over 1. 3 is an integer, 1 is an integer, so these are rational numbers. But if you consider root 2 can be expressed as root 2 over 1. I admit 1 is an integer, but root 2 is not an integer. It's not an integer. So root 2 is not an integer, which means this is not a rational number. So what are rational numbers? We have done that before. This is not the first time that you are hearing rational numbers. If we can express a number as a ratio of two integers, those are rational numbers. The same thing goes with rational functions, a ratio of two polynomials. A ratio of two polynomials is considered as a rational function. So what is a rational function? A rational function is like fx over gx, fx over gx, where fx is even a polynomial, fx is even a polynomial, and gx is even a polynomial. So both fx and gx are polynomials. So then the ratio of two polynomials is considered as a rational function. So that one we have to learn first, because the definition of partial fractions comes with rational function. ඒ කියන්නේ අර partial fraction කියන එකේ definition එක ඇතුලේ තියෙනවා rational function කියන එක. ඒතකොට මුලින්ම we have to consider what is a rational function. That's why I gave it. Okay. Okay, you wrote this note, rational functions, write this. The ratio of two polynomials, the ratio of two polynomials, the ratio of two polynomials is considered as a rational function. The ratio of two polynomials is considered as a rational function. Rational function. Then just write this rational function is fx over gx, where fx and gx are polynomials. Where fx and gx are polynomials. Fx and gx are polynomials. Okay. Okay. So if I take few examples, examples, 2x are divided by x squared plus x. It's a rational function because this is a polynomial, this is a polynomial. Then we have x squared minus 1 divided by x cubed plus 3x minus 7. This is a polynomial and this is a polynomial. Okay, now I want you to tell me, if I write 1 over x plus 1, okay, if I write 1 over x plus 1, okay, so why these are rational functions? This is a polynomial, 2x is a polynomial, and x squared plus x is a polynomial. X squared plus x is a polynomial. So this is a polynomial and even this is a polynomial, which means these are rational functions. But now I want you to consider, I have written 1 over x plus 1. I admit x plus 1 is a polynomial. Is a polynomial. Okay, tell me, is this 1, is it a polynomial or not? 1, is it a polynomial or not? Hands up if you are telling that 1 is a polynomial. Yes, 1 is a polynomial. Hands up. Few. Hands up if you are telling 1 is not a polynomial. Okay, now I want you to do this. Okay, now tell me if you can remember the general polynomial. Like anyone who haven't done polynomials, that's okay. Yeah? Like when I'm talking about these degrees, I'll explain what are them. For now, I'm just working with the ones who know polynomials. The newcomers who don't know polynomials, you don't have to worry about it. Okay. Other part okay, now tell me, what is the general polynomial with degree 1? A first degree general polynomial? Ax plus b. A second degree general polynomial? X squared bx plus c. A third degree polynomial? It continues ax cubed, bx squared, cx and d. So if the degree is 1, first degree polynomial, you told me ax plus b. Second degree polynomial, you told me ax squared. It continues and this is ax cubed. And now if I ask you, what is a 0 degree polynomial? What is a 0 degree polynomial? It's a constant. A 0-degree polynomial is a constant, which means 1 is a constant, so it is even a polynomial. A constant is a polynomial, so this is even a polynomial. A constant it's a polynomial. Here, even it's a polynomial, which means 1 over x plus 1, it is a polynomial. Clear? 1 over x plus 1, it is a polynomial. Always keep in mind that even a constant is a polynomial. It's a 0-degree polynomial. Okay, write these examples. So we discussed about rational functions. What are rational functions? And write these examples. Okay, so these are rational functions. So I told you, when we are defining what is a partial fractions, we should know what is a rational function. Now you know what is a rational function. Rational function එකක් මොකක්ද කියලා දන්නවා. Okay, so how can we define partial fractions when a rational function, so these are rational functions, when a rational function is split like the rational function has been split, we can consider that it has broken down or like decomposed. So normally what we use is decompose, like decomposition. Make a decomposition can science will apply decomposition. So even if you can remember chemistry at least a bit, you learned about these decomposition reactions. No? You had those, no? For O levels, you had those. One I can remember, if you heat calcium carbonate, you get something like calcium oxide and carbon dioxide. So like that is a decomposition reaction. So best example, you have calcium carbonate, when you heat it, you get calcium oxide plus carbon dioxide. You had them for O levels, no? Okay, so those we name as decomposition reactions. So why decomposition reactions? Is because that calcium carbonate has been decomposed into two components, two or maybe three. Clear? So that's why we consider those as decomposition reactions. So even here, we consider the decomposition of part of rational functions into the initial fractions that the rational function was made of. That is, we consider those initial fractions as partial fractions. These initial fractions are considered as partial fractions, and this process, the thing that we are doing here, the process is named as decomposition to partial fractions. Nothing we can say splitting into partial fractions or breaking down into partial fractions. Okay, so let's go with this one. Right, in this way, let's consider the following fractional simplification. Let's consider the following fractional simplification. Let's consider the following fractional simplification. We can write this one, 1 over a plus 1 over b is equal to, you can look at the board, a plus b over ab, which means a plus b over ab is equal to this. Is equal to 1 over a plus 1 over b. Okay. Okay, write this after this one, right? It is clear 1 over a and 1 over b. It is clear 1 over a and 1 over b get together and give the above fractional expression. And give the above fractional expression. Which means 1 over a and 1 over b, which means 1 over a and 1 over b are, write in a red pen, partial fractions. Only that word write in a red pen. 1 over a and 1 over b are partial fractions of the above expression. Of the above expression. of the above expression. Okay, so then you can just mark them as partial fractions. So what are partial fractions? The fractions, the initial fractions that a rational function is made of are considered as the partial fraction. So what is a partial fraction? The simplest format of the initial fraction. So there is one added term. It should be in the simplest way. So that is the additional one. It should be in the simplest way. The simplest form of the initial fractions that a rational function is made of are considered as the partial fractions. Okay, write in this way, next line. Write in this way, next line. The simplest form, the simplest form, the simplest form of the initial fractions, the simplest form of the initial fractions, a rational function is made of, a rational function is made of, are considered as the partial fractions, are considered as the partial fractions of the rational function, of the rational function. Okay, so it is clear. So show this, when you add these two, you get this one. Now get this example. So this is a rational function. When you add these two, you get this. So when you break down them, you get the partial fractions. So this is a rational, so this is a rational function. So this is a rational function. So these are the partial fractions of it. These are the partial fractions of it. Okay, so first write this one, show that when you add these two, you are getting this one. So this one is equal to 2 over x plus 1 over x. This is a rational function, and these are the two partial fractions. It's only not only limited to 2, okay, there can be 3, 4, any number. So these are the partial fractions. Okay, write it this way, the process of splitting a rational function, the process of splitting, use L, the process of splitting a rational function into its partial fractions, is known as, write in a black pen, decomposition of a rational function. Write in a black pen, decomposition of a rational function. Okay. So there are two types of rational functions, and based on these two types of rational functions, there are two ways of splitting into partial fractions. So there are two types of rational functions. Based on these type of the rational function, there are two types of partial fractions that we have to discuss. So today we'll be entirely discussing about one type of rational function, and next week we will be moving on to the next type. So when we are talking about these fractions, if I say this A over B, so you know that there are several types of fractions. Can't sleep. Okay, so there are several types of fractions. No? You know, like the basic fraction, what we know is a proper fraction. It's a proper one. And then we have the opposite of that, improper. Improper, what is the, it's improper, yeah. So it's improper. And we have mixed fractions, unit fractions, different equivalent fractions, different fractions. But if I ask you to categorize fractions into two categories, there are only mainly two categories. Either whether it is a proper fraction or it is an improper fraction. So that is the main categorization, whether it is proper or improper. So how do we decide whether it is proper or improper? Based on the magnitude of the numerator and the denominator. We can remember if the numerator is smaller than the denominator, we call it as the numerator is smaller than the denominator, we call it as a proper fraction. If the numerator is big, we call it as a improper. It's improper. So that's why when the numerator is bigger than the denominator, we consider it's an improper fraction. So same thing, there are two types of rational functions. So there are two types of rational functions based on this numerator and the denominator. But the thing here, rational functions are polynomials. No, it's a ratio of polynomials. It's a ratio of polynomials. Okay, it's a ratio of polynomials. So there is no any way that you can compare the magnitude of a polynomial. Can you say whether x plus 1 is greater than x squared minus 2? Can you say? You can say that 7 is greater than 2. You can compare 7 and 2. Can you compare x plus 1 and x squared minus 2? No, there's no any way that you can compare polynomials. But normally, if you can remember, when we were discussing a particular term for a polynomial, I told you that is how we categorize a polynomial. Tell me, polynomials are categorized based on what? The degree. Can remember. Okay. So polynomials are categorized based on the degree. Okay. So here, it's a first degree polynomial. Here it's a second degree polynomial. So it's categorized according to its degree. So newcomers who haven't done this polynomials lesson, just learn. That's all we need. Degree is the highest power. That's all. Okay. So the new word that you are learning today, degree is the highest power in the polynomial. So you don't have to consider, because there are some students who have been here even in from day one, but still they can't remember what is the degree. So no difference. Okay, there's no any huge difference at the beginning. So everyone, if you can't remember what is a degree, degree is the highest power of a polynomial. So here it's 1, here it's 2. Okay, so if the degree, same thing, we say if the degree of the numerator, if the degree of the numerator is less than degree of numerator is less than the degree of the denominator. That means a normal case. The denominator is greater than the numerator. So here we are comparing the degrees. So here, since it's normal, we consider this as a normal rational function. It's normal. It's a normal rational function. Clear? So when the numerator's degree is less than the denominator's degree, we call it as a normal rational function. So what is the opposite? When the degree of the numerator is greater than, or we consider equal. The equality is considered here. When the degree of the numerator is greater or equal to the degree of the denominator. You can write I just skip the word the degree of the denominator. Okay, so this is when the numerator is smaller than the denominator, it's normal. So this one you don't consider as abnormal. So here we consider it as a special rational function. This one is a special rational function. This is a special rational function. So there are two types of rational functions based on the degrees of the numerator and the denominator. It can be either a normal rational function or it can be a not abnormal. We call it as a special rational function. Okay, write in this way. There are two types of rational functions. There are two types of rational functions based on the degree, based on the degree, based on the degree of the numerator and the denominator. Based on the degree of the numerator and the denominator. Based on the degree of the numerator and the denominator. Okay, then first consider this one. Rational function is fx over gx. And show that if the degree is less, the numerator's degree is less, it's a normal rational function. If not, it's a special. So there are two types of rational functions, normal rational functions and special. Okay, write the main topic. Write the main topic. Decomposition of normal rational functions. Write the main topic. Decomposition of normal rational functions. Normal rational functions into partial fractions. Into partial fractions. Decomposition of normal rational functions into partial fractions. Okay. Okay. Now I need you to properly focus. So this is the first question that we will be doing. I'm asking you to split this into partial fractions or decompose this into partial fractions. Okay. So this is the tute. So I have given a tute for this basic algebra. Now the first page, first 4 pages are the same, that basic mathematical concepts that we used to have, what we did. And then we have recurring decimals, the same one, and we have inequalities. I have added some more inequalities under proving of inequalities. And now is the next one is partial fractions. Okay, so next lesson and the same, we are having some more lessons here, logarithms, functions, coordinate geometry, and modulus functions, few more lessons. Okay, so here, for the students who have joined online, I have uploaded the tute in the group. So question number 1 is separate the following rational functions into partial fractions. Okay, so okay, this is how we do this. Now I need you to properly focus. මේක තමයි හොඳම ටික. ඒ කියන්නේ මේන්ම ටික lesson එකේ මේන්ම ටික මේක. Now we need to find partial fractions. Okay, now focus. Look at the board. නිදිමත ඉන්න බෑ. Can't see any sleepy faces. I need a proper attention. Listen, look at the board. Look at the board. No sleepy faces. A bit sleepy, no? Okay, good. Okay, now look at the board. So what is the first step when we have to split this into partial fractions? Is first you have to completely factorize the denominator. First, just check whether the degree, you can check the degree here. No? So here is a first degree polynomial. Here the degree is 1. And here the degree is 2. So how come the degree here become 2? Because x into x give you x squared. So like this one, like every question that we are doing today comes under a normal rational function. But let's say you are getting to split a rational function in the exam. First one you have to check whether it is normal or special. So first check the denominators and numerators degree. Clear? But today we will be only working with normal ones. So you don't have to do that check. Okay, so step number 1 is we have to completely factorize the denominator. Completely we have to factorize the denominator that we have done. And then the second step is we have to write fractions by taking each of these factors as the denominator. Now I need to write fractions by taking each of these factors as a denominator, which means one denominator we got x plus 1, the other denominator we got x minus 1. So I need, we need to write fractions by taking each of these factors as the denominators. Okay, now tell me, if we have 3 factors in the denominator, how many fractions will be here? Talk, 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 talk. If we have 3 factors in the denominator, how many fractions we are going to write? 3 fractions. So that is step number 2. Step number 3 is, so here we know the degree of the denominator is 1. We know that the degree of the denominator is 1. Step number 3 is we have to put a polynomial with a degree with a degree which is 1 less than the denominator's degree. As the numerator, we have to put a polynomial such that the numerator's degree is only 1 less than the denominator's degree. Which means here the degree is 1. Here even the degree is 1. So as the numerator, I need to put a polynomial with a degree that is 1 less than the denominator. So here it should be a 0 degree polynomial. Even here and here, it should be a 0 degree polynomial, because here the degree is 1. 1 degree lesser than means the degree is 0. So this is the only other part that the newcomer should know. I explained one thing is the word degree. Okay, this is the other part that you need to know. So towards the right hand side of your book, the newcomers can write, and students, if you can't remember this, you can even write it. You can even, you were in the class but you can't remember this, you can write it. General polynomials, just towards the right hand side of your book. Especially newcomers and students who can't remember this, even write it. General polynomials. You can write a general polynomial when the degree has been given. Okay. So if the degree is 0, if the degree is 1, and I'll just write one more. Only we need is the 0 and the first degree, but I'll just write even the second degree. So when the degree is 0, the general polynomial is a constant. You can use any letter, A, B, C, any letter. It's a constant. When the degree is 1, a first degree polynomial, so that's what this guy gave the answer. The first degree polynomial is in general ax plus b. And then they gave the answer. The second degree polynomial is ax squared plus bx plus c. I'm not going to write the third degree polynomial because under partial fractions, we'll be only working with these two. Okay, so we need to know them. Anyone who is a newcomer, you can write this towards the right hand side of the book, general polynomials. When the degree is given, how can we take a general polynomial? Okay. Okay, so after writing that, I told you as the numerator, we need to put a general polynomial or a polynomial which is having a degree 1 degree less than the denominator. So here 0 degree means a constant. So I'm using A here and I'm using B here. I'm using A because after using A, you can't use A again. So I'm using A here and I'm using B here. And last step is using a suitable method, I should find A and B. Using a suitable method, I should find this A and B. So that is step number 4. I'll explain later. Later means after giving this note, I'll explain how to find the degrees A and B. Clear? So this is simply the process of breaking down into polynomials or decomposition into polynomials. Factorize the denominator, then write these fractions, put in the factors of the denominator separately, and based on the degree of the denominator, you have to put the numerator. You have to put your own numerator. It should be 1 degree less than the denominator's degree. And then step number 4, using a suitable method, find A and B. That I'll explain how to find A and B. Okay, hands up who got this idea of how to split into partial fractions. Okay, write in this way. Write in this way. A normal rational function, a normal rational function is splitted into partial fractions, according to the following steps. according to the following steps. Under that, the first one, you can either number it or put a bullet or dash or anything. Munahari dande. You can either put 1, 2, 3. First one is the denominator should be completely factorized. The denominator should be completely factorized. Completely factorized. Second step. Okay. Partial fractions should be written. Next step. Partial fractions should be written. Partial fractions should be written by taking each factor of the denominator, each factor of the denominator, each factor of the denominator as the denominator of the fraction, as the denominator of the fraction, as the denominator of the fraction. Okay, step number 3. A general polynomial should be taken as the numerator. A general polynomial should be taken as the numerator. Should be taken as the numerator such that the degree of the numerator is less by 1. The degree of the numerator is less by 1 than the degree of the denominator. Than the degree of the denominator. Last one. Using a suitable simplification method, using a suitable simplification method, the constants should be calculated. The constants should be calculated. The constants should be calculated. Okay. Clear. Then take this example question number 1. So here I have they have completely factorized it. So then I have to consider fractions by taking the different factors as the denominators. Can we make a denominator in factors වෙනම ඉන්න විදිහට fractions ලියන්න එච්චරයි. Denominator ඉන්න factors ටික වෙනම ඉන්න විදිහට ඔයා ලියන්න factors ටිකක්. Fractions ටිකක්, sorry. Newcomers, better to write that one towards the right hand side. What are the general polynomials, and because we'll be using it here. Okay. Okay, now the important part. Now we need to find A and B. The main part. Okay, you need to find A and B. I'm supposed to find A and B. So what we do here is a common simplification to find A and B. So what I do, I multiply both sides by this denominator. I multiply both sides. Look at the board, okay? The best one, and then you can do the best part, the main part of the simplification, and then you can do by your own. No sleepy faces. Okay. If you're really sleepy, I know the time is a bit sleepy, not bit sleepy. The time is sleepy because 3 o'clock, 4 o'clock. Every day I tell you, like if you at home by this time, you would have sleeping. That's the most probably the thing is that what you would do, you will be sleeping at this time. I don't expect that you're watching cartoons, but if you're watching cartoons, that's okay. But mainly you'll be sleepy. So here it's a sleepy time. So if you feel really sleepy, you can just take some water, the nan depa, some water to your hand, and you can just do it. Then that's okay. And if you can't tolerate, I'm totally fine. You can go. There's a washroom here. Then you can just go and wash your face, and when you can take a bath and come if you want. But you have to come here and stay in a fresh phase, okay? Because I admit that I'm is sleepy. I don't admit that my voice is sleepy. But I admit that the time is sleepy, okay? Okay. Now what I do here, okay, now listen. Now what I do here is I multiply by this denominator. So as the first one, I'll just write this. So when you multiply by the denominator, what happens? You don't have to write in this way, but since it's the first simplification, I'll be multiplying. So when you multiply, you don't have to write this, okay? Because you know when you multiply by this denominator, this will be remaining, but I'm just writing because it's the first simplification. And even this side, each term should be multiplied by x plus 1 or x minus 1. And then this one be over x minus 1 should be multiplied by x minus 1 and x plus 1. Clear? So now we can see a clear simplification. These two cancel off. X plus 1 cancel off and x minus 1 cancel off. So here we have 2x minus 1 is equal to a times x minus 1 plus b times x plus 1. Okay, 2x minus 1 is equal to a times x minus 1 and b times x plus 1. So what I expect here is after writing this one, you can directly write this. You are supposed to write this after this question from next question. I won't be writing this step. You don't have to write it this one. You know when you multiply, these two cancel off. X plus 1 cancel off, x minus 1 is remaining. X minus 1 cancel off, x plus 1 is remaining. Okay. So somehow you have come to here. No? So what am I supposed to do? Find in A and B. So if there's a student who just do a decent amount of work at home, like I'm not talking about working really hard, who is doing a decent amount of work at home, he or she should remember that this is the first page of the polynomial state. He or she should remember that this is the first page of the polynomial state. We had to find constants such that these two are equal. So there are two main ways, but I'll explain because there are newcomers. There are two main ways. So first method is either you can compare the coefficients or you can substitute values. So I'll explain the both methods. So what is method 1 is comparing, or there's another word, equating coefficients. Comparing, or even you can say equating. Simply making them equal, equating coefficients. So this is the first method. Okay, so what we do here, silence, listen. First, you need to rearrange the right-hand side. So when you expand, it's ax minus a plus bx plus b. So when you rearrange, you can consider the coefficient of x is a plus b. And here I have minus a plus b. So what is this method is equating coefficients or comparing coefficients. No? So what we do here is you can simply make the coefficient of x equal to the coefficient of this. You are making the two coefficients equal. You are making the two constants equal. You are making the two constants equal. So when you consider the coefficient of x, bring it to the Cafe. Make sure your phones are silent or bring it to the but make sure other phones are silent. Your phone should be silent. So here, okay, listen. Silence. Okay, done. That's done. So here, okay, silence. I'm comparing the two coefficients. So when you compare the coefficient of x, it's a plus b is equal to 2. So that is the first simultaneous equation. The next one is you can compare the coefficient. Here it's a, sorry, constant. Here it's a constant and here is a constant. So there, when there is no any x, it's a constant. So here the constant is minus a plus b. The constant here is minus a plus b is equal to minus 1. Okay, then you know that minus a plus b is equal to minus 1. So what we have to do is find in a and b. It's a matter of simultaneous equations simplification. Simply add these two, which gives you a plus b minus a plus b is equal to 2 minus b. 2b is equal to 1, which gives you that b is equal to half. So I get 1 constant, b is equal to half. You can find the other by substituting. So simplification, I need you to do alone, okay? After coming up to this one, there are two methods. I'll explain the both methods. So if you substitute the first one, half plus b is equal to 2. B is equal to 2 minus 1 over 2. So it's 4 minus 1 divided by 2. So I get B is equal to 3 over 2. Clear? So what I want, sorry, it's what did I do? I substituted B. So it's A plus B. So here, it's, okay. So A is equal to 3 over 2. So what I want to do is find in A and B. So after coming to this step, there are two main ways. So everyone, like even you are a newcomer, you can easily understand. Expand this and take all the x terms together, constants together, and when there are x squared terms, take them even together. And equate or compare the coefficients, make them equal. Clear? Okay. So do this and come up to this step, find A and B. So this is the first method, comparing or equating coefficients. This is the first method, comparing or equating coefficients. After writing the two simultaneous equations, simplify them alone. Because you can simplify simultaneous equations, no, that you can do. Okay, so what is the other method? Method number 2 is substituting values. The other method, let's take it as method 2. Okay, so here it's, we call it as substituting values. Substitution of values. Okay, so if you can remember, what we do here is look at this. So we have to come up to this step. Either ways that you do, you have to come up to this step. 2x minus 1 is equal to a times x minus 1 plus b times x plus 1. So what we do here is we need to substitute values such that each of these factors become 0. අපි x වලට මේව දාන්න ඕනේ වෙන මේව බිඳුව වෙන විදියට. Like we have to substitute values such that each of these factors are 0. Clear? Each of these are 0. So this one becomes 0 when x equals 1. So what you have to do is substitute x equals 1. Substitute x equals 1. So when you substitute x equals 1, you have to substitute both sides. Here it's 2 minus 1. A times, you don't have to write this. For now, I'll just write it because I told you when it is 0, you don't have to write it. You know that is 0, but for now, I'll just write it. So a 1 minus 1 becomes 0. So simply it goes away. Then you directly get the value of b, that 2 minus 1 is 1 is equal to b into 2. B is equal to half. So you get the value that b is equal to half. The same way, you can substitute x equals minus 1 in order to make this 0. So I'm putting x equals minus 1. I'm putting x equals minus 1 to make this 0. And then here it's 2 times minus 1. Minus 1 is equal to a times minus 1, b times minus 1 plus 1. So I told you, like, you don't have to write this here after. When you can see someone becomes 0, don't write it. Simply ignore it, it's 0, no? Okay, so here what we have, minus 2 minus 1 is equal to a into minus 2, which gives me minus 3 divided by minus 2 is equal to a, and then a is equal to 3 over 2. So even from using this method, you can get the answers a and b. Okay, so write the second method, method 2, substitution of values. So here we know that we substitute values such that each of these factors becomes 0. So where at x equals 1, this becomes 0. At x equals minus 1, this becomes 0. Okay, to this method number 2. What are the values that we are selecting here, especially newcomers? We have to select values such that these factors are 0. So this becomes 0 when x equals 1. This becomes 0 when x equals minus 1. So you are substituting those values. We are not just substituting random values. We are substituting values that make these factors 0. That make these factors 0. Clear? Okay. So after finding a and b, like what we were supposed to do is find the partial fractions. No? So then write the final answer in this way. So 2x minus 1 over x minus 1, x minus 2, you have taken that a is equal to 3 over 2 divided by x minus 1 and b is equal to half divided by x minus 2. Okay, a is equal to this and this way. But you know, normally we don't keep this in this way, and it's like even double-decker buses are having more floors. So we don't keep fractions in this way. What you can simply do is you can take this denominator down. You can take this denominator down. We have done those under basic mathematical concepts. So what is your final answer? The final answer should look in this way, x plus 1. What's x plus 1? X minus 1 and x plus 1. So the final answer is in this way. I is equal to 3 over 2 times x minus 1. And when 2 comes down, 1 over 2 times x plus 1. So this is the final answer. We have splitted this into, we have decomposed, or we have broken down this into two partial fractions in the simplest format. In the simplest format. Okay, write your final answer and do question number 2, 4, and 5 in the tute. So write the final answer. And in the tute, do questions 2, 4, and 5. I have changed this. This one should be x plus 1. This one should be minus. Yeah. So even here it's x plus 1. Silence. Do question number 2, 4, and 5. A easy part. Silence. Stop talking. Just do the work. It's an easy part. Everyone should understand. Even though a newcomer or not, everyone in the class should be able to do this properly. Easy part. Okay, I'll do question number 2. So first, write this in this way. A over x minus 2 plus b over x minus 3. Then multiply by this denominator x minus 2 and x minus 3. So when you multiply, I told you, you don't have to show that each factor is cancelling off. Just write the final one. It's x plus 1 is equal to a times x minus 2 cancel off, x minus 3 is remaining. X minus 3 cancel off and x minus 2 is remaining. Okay. Okay, so make each factor equal 0. So you can put x equals 3. When you have x equals 3, it's 3 should be substituted. 3 plus 1 is equal. You don't have to write this, okay? Because you know that it is 0, don't write it. So here b into 3 minus 2 So 4 is equal to b into 1 and you get that b is equal to 4. And then put the next one. You can make this become 0 by putting x equals 2. So when x equals 2, it's 2 plus, it's 2 plus 1 equals, just write this one, a 2 minus 3 because this is 0, no? 3 is equal to minus 1, then a is equal to minus 3. So you get a is equal to minus 3. Then you can write the final partial fraction x plus 1 over x minus 2 and x minus 3. It's equal x minus 3. This is equal to, what is a? A is minus 3 over x minus 2. What is b? It's 4 plus 4 into x minus 3. Clear? So then I can get this answer in this way. Okay, then question number 4. X minus 3 divided by x times x plus 1. No? X minus 3 divided by x times x plus 1. Okay. Okay, this one, same thing. I'll write this as a over x plus b over x plus 1. Okay, now you can multiply by x into x plus 1. What do I have? X minus 3. And if x cancel off, x plus 1 will be remaining, and this is b into x. Okay. So you have the freedom to use any of the methods. Like even though I'm using substitution of values like in a higher frequency, that doesn't mean that is the only way. So for example, this one you can do by comparing coefficients. I'll do it by comparing coefficients. Ax plus a plus bx. So it's a plus b into x plus a is equal to x minus 3. So here directly you can say, because the only constant here is a, no? So directly you can take the value of a. If you compare the constant, a is equal to minus 3. A is equal to minus 3, clear? Because this is the only constant. And now when you consider x, now when you consider x, there it's a plus b, it's equal to 1. A is minus 3. So b is equal to 1 plus 3, b is equal to 4. Is it what you get? A is equal to minus 3 and b is equal to 4. Okay. Okay, so what is the final answer? The partial fraction x minus 3 over x into x plus 1. This is equal to, what is a? A is minus 3 over x plus b. What is b? It's 4 over x plus 1. Clear? Okay, hands up who got question number 2 and question number 4. These two answers correctly got in. Okay, good. Do after this, do question number 5 and then 7. Do this question number 7, 9 and 10. I don't make them, I can't repeat. And everything is not a joke every time. Keep that in mind. Silence, silence, silence. Do question number after doing 5, 7, 9 and 10. 7, 9 and 10. Okay, continue the work. I'll do question number 5. 3x plus 1 over x plus 1, x minus 3. Question number 5, 3x plus 1, x minus 1, x plus 3. X plus 3. Okay, x minus 1 and x plus 3. So here I is equal to a over x minus 1 plus b over x plus 3. B over x plus 3. So what we can do is we can multiply by the denominator x minus 1 into x plus 3, which gives me in the numerator it's 3x plus 1 remaining. Here a into x plus 3 and b into x minus 1. So you can substitute values such that these factors become 0 when you put x equals minus 3. When you put x equals minus 3, it's 3 into minus 3 plus 1 is equal. You don't have to write this, it becomes 0. Minus 3 minus 1. So here it's minus 9 plus 1 is equal to b into minus 4. So b is equal to minus 8 divided by minus 4, which becomes b is equal to 2. And then consider x equals 1, x equals 1. So when x equals 1, this becomes 0. It's 3 plus 1 is equal to a times 1 plus 3. You don't have to write this, it becomes 0. 4 is equal to a into 4, which means a is equal to 1. So I get a is equal to 1 and b is equal to 2. So we can write the final answer. What is the partial fraction? 3x plus 1 over x minus 1, x plus 3. This is equal to a. What is a? It's 1 over x minus 1 plus b. It's 2 over x plus 3. Okay, so question number 7, I have written the answer directly. Make sure you have taken the correct answer. 1 over x minus 1 plus 1 over x minus 2. Okay. Okay, so here the first step under partial fractions is that we have to factorize this. No, completely the denominator should be factorized. What is the factorization here? X minus 4 and x plus 1. So when you factorize this, you get this. So then I'll be working with that. Okay, now split this into partial fractions. A over x minus 4 and b over x plus 1. Okay, so here now I'll be working entirely with this one. This one is done. After factorizing, we got this one. So I'll be working with this. Okay, so when you multiply by x minus 4 and x plus 1, when you multiply by x minus 4 and x plus 1, I get 3 minus 2x is equal to a times x minus 4 cancel off its x plus 1 and x plus 1 cancel off its x minus 4. So substitute x equals minus 1 to make this 0. X equals minus 1 to make this 0. It's 3 minus 2 into minus 1. This becomes 0, then only write this one. It's minus 1 minus 4, clear? So when you simplify, you get 3 plus 2, which is equal to b into minus 5. B is equal to 5 over minus 5. So b is equal to minus 1. So I get b is equal to minus 1, clear? Okay, next one, substitute x equals 4. Or substitute x equals 4. So when x equals 4, 3 into 2 into 4 is equal a times 4 plus 1. You don't have to write this one, it becomes 0, no? So here it's 3 minus 8 is equal to a into 5. So here it's a is equal to minus 5 divided by 5. So you get both minus 1, no? So both a and b is -1, Okay. So then you can write the final answer. It's 2x, sorry, 3 minus 2x are divided by x minus 4, then x plus 1. Okay, this is equal to, what is a? Both is -1 over x minus 4 -1 over x plus 1 -1 over x plus 1. Okay. Okay, hands up who got this ninth one. -1 over x minus 4 -1 over x plus 1. Okay. Okay, question number 10 is 3x plus 2 x plus 1. Okay. Question number 10, 3x plus 2 over x plus 1 2x plus 1. So even here it's 1 and 1. No? Okay, let's see. So if you take a over x plus 1, a b over 2x plus 1. Okay, silence. Same drill, same thing, multiplied by x plus 1 into 2x plus 1. Then what is remaining here? It's 3x plus 2 remaining here is equal to a times 2x plus 1, b times x plus 1. So what is remaining here? A times 2x plus 1 and b times x plus 1. Clear? Okay. So you can make this factor equal 0 when you put x equals minus half, because this becomes 0 when x is equal to minus half. Okay. So you can put x equals minus half when x is equal to minus half. It's 3 into minus half plus 2. You don't have to write this one. Like you don't have to like write this and show it 0. Just keep it that way. It's 0 minus half plus 1. Okay. If you take 2 as the common denominator, -3 plus 4 divided by 2. And even here -1 plus 2 divided by 2. So it's clear 2 cancel off. It's 1. And even here it's 1. B is equal to 1. So simply you get B is equal to 1. And when you put x equals -1, the easier one. When you put x equals -1, here it's 3 into -1 plus 2 is equal to, this is the only remaining one, no? A times -2 plus 1. Because when you put -1, this becomes -2. This is anyway 0. No? -3 plus 2 is equal to a into -1. Okay, clear. So here it's -1, a into -1, which means a is equal to 1. So I get a and b are equal to 1. Then you can write the final answer, the final partial fraction. 3x plus 2 over x plus 1, 2x plus 1 is equal to 1 over x plus 1, 1 over 2x plus 1. Clear? Okay, I'll give you like 1 minute, drink some water. Complete the work first and then drink some water. Okay, now look at question number 13. Silence, okay. So it's 3x plus 1 divided by, so when you hear my voice, just be silent. Huh? X minus 1, x plus 2 into x minus 3. So same thing, because I didn't, when we were doing these kind of partial fractions, I didn't separately give a topic, no. When we have only 2 factors in the denominator, no, I didn't like specify in that way. So the same thing, like no matter of how many factors you got in the denominator, if it is a normal, the rational function, Here the degree is 3 because you are getting x cube, and here the degree is 1. So when it is a normal rational function, you have to do the same thing. Same drill because it's a normal one. Here the degree is 3, a third degree polynomial, and here the degree is 1, a first degree polynomial. Okay. So then it's equal to, we are having three fractions, a over x minus 1, b over x plus 2, and c over x minus 3. Multiply by this denominator, x minus 1, x plus 2, x minus 3. Okay, so here the entire denominator will cancel off. So what are remaining? 3x plus 1. Don't write this in. It's 3x plus 1. Here after x minus 1 cancel off, it's x plus 2 and x minus 3. X plus 2 cancel off, it's x minus 1 and x minus 3. And here x minus 3 cancel off, it's x minus 1 and x plus 2. Clear? And same thing, you can, when you substitute x equals, let's go with the easier one. When you substitute x equals 1, what happens? Look at this. So what happens? This becomes 0. This becomes 0. Both of them become 0. Only here we have, so 3 plus 1 is equal to a into 1 plus 2 plus 1 minus 3. So you don't have to write it. අර බින්දුවයි කියලා දැක්කහම ලියන්න එපා බොරුවට. ෂුවර් නෑ. like ලියලා බලමු. Let's write and see whether it is 0. No, it becomes 0. You don't have to check it. It's 0. Okay, so don't waste your time to write the things that become 0. So it's 4 is equal a into 3 into minus 2, no? Did I do a mistake? No. No mistakes, no? All good. 3. So this is 1 plus 2. Okay. So when you simplify, you can see here is minus 2 and here cancel off. It's 2, but there's a minus remaining. So a is equal to 2 over minus 3, minus 2 over. So next one is when we put x equals 2, x equals minus 2, because this factor becomes 0 when x equals minus 2. So if you have attended classes properly, then you know that we have done these kind of questions. No, under polynomials, we have done this find in ABC values. So when you put minus 2 here, it's 3 into minus 2 plus 1. Here it becomes 0. Don't write it. This becomes 0. So only remaining one will be minus 2 minus 1 and minus 2 minus 3. Clear? A minus 6 plus 1 is equal to b into minus 3 into minus 5. So when you simplify, it's minus 5 into b, minus 3 into minus 5. So minus 5 cancel off. And you can find b, and then you can easily find c. Clear? So b is equal to 1 over minus 3, which is minus 1 over 3. The last one, put x equals 3. The other factor, put x equals 3. So when you put x equals 3, what happens? Here, 3 into 3. Here this factor is 0. This factor becomes 0. Only remaining is this c into 3 minus 1 and 3 plus 2. Clear? So it's 9 plus 1 is equal to c into 2 into 5. So 10 is equal to c into 10. No? So I get c is equal to 1. So after getting c equals 1, b and this one, you can write the final answer. Clear? Okay, hands up if this is clear, whether this is clear. Okay, good. Do this one, question number 13, 14, and 17. So you don't have to look at the board. Two questions, 13, 14, and 17. So write even the final answer. The final answer, it's 3x plus 1 divided by x minus 1, x plus 2, x minus 3. It's equal to a. What is a? Minus 3 over 2, x minus 1. What is b? Minus 1 over 3, x plus 2. And what is c? 1 over x minus 3. We can write the final answer when 3 comes down. Minus 2 over 3 times x minus 1. This is minus 1 over 3 comes down. So how did this become minus? Because plus minus is minus. Final one is 1 over x minus 3. So you keep the final answer in this format. Okay. So I have done 13, do 14 and 17. Silence, silence. When you're doing like, when you're simplifying, do it, focus and do it. Then you won't do any simplification mistakes. Okay, so what we have in question number 14, x minus 1 over 2x minus 1, x plus 1 and x minus 3. Okay, so here it's a over 2x minus 1 and b over x plus 1 and c over x minus 3. C over x minus 3. Okay, multiply by the denominator 2x minus 1, x plus 1 and x minus 3. So here it will be x minus 1. And here it's when 2x minus 1 cancel off, it's x plus 1 and x minus 3. X plus 1 cancel off, it's 2x minus 1 and x minus 3. Last one is 2x minus 1 and x plus 1 because x minus 3 cancel off. Okay. Okay, now simply substitute the values. So let's start with x equals minus 1. X equals minus 1. So when x equals minus 1, here it's minus 1, minus 1. You don't have to write this one, because it becomes 0. The only one will be this, b into 2x minus 1. So when you put minus 1, it's minus 2 minus 1. Minus 1 minus 3 is equal to minus 2. B into minus 3 into minus 4. So you can simplify according to any way that you like. So when you take it, b is equal to minus 2 divided by minus 3 into minus 4 is plus 12. So b is equal minus 1 over 6. B is equal to 1 minus 1 over 6. Okay. Then put x equals minus 3. Sorry, x equals 3. When you put x equals 3, okay, when you put x equals 3, you got 3 minus 1 is equal to, don't write this one, don't write this one, only write this. 2 into 3 minus 1, 3 plus 1. So it's 2 is equal to 6 minus 1 and into 4. So you can simplify, it's 2. It's c into 5 into 2. So I'm getting 10c is equal to 1. C is equal to 1 over 10. Got this? This is okay. Minus 1 over 6, 1 over 10. Got it? No. Hands up who got these two values, minus 1 over 6, 1 over 10. Okay, the last one is a fractional one. Substitute x equals x equals half. So when you put x equals half, this becomes 0, this becomes 0, and these two will be only here. Half minus 1 is equal to a into half plus 1. into half minus 3. Clear? So take 2 as the common denominator. It's 1 minus 2. Here again 2 as the common denominator, 1 plus 2. Again 2 as the common denominator, 1 minus 6. So 1, 2 cancel off. It's minus 1 is equal to I into 3 into minus 5 over 2. So when you simplify this, you get minus and minus cancel off, and I'm getting A is equal to 2 over 15. A is equal to 2 over 15. Got it? Okay. Okay, now look at this. So when you are writing the final answer, okay, now look at this. So when you're writing the final answer, it's x minus 1 divided by 2x minus 1, x plus 1, x minus 3. And it's equal this way. Okay, now look at this. Just 1 minute. Look at the board. So here, when you're writing the final answer, you have taken that a is equal to 2 over 15. So you know when you put it here, 15 comes down, no. So what you can do, like every time I mention, do the simplification according to your level. Because by now, you know whether you are good in simplification or whether you are moderate or whether you are weak in simplification. That you know. No? So like forget about your logical thinking, analytical thinking, all. By now, you know your capacity when in terms of simplification, whether it is good, perfect, moderate, or it's a bit weak. So always I'm telling you, do the simplification not according to your friend's one, do it according to your level. So what you can do here, you know what happens here. So when I put this in this way, a becomes 2 over 15 over 2x minus 1. No? So what I can do is, you don't have to write this in this way. You know directly 15 comes down. So I'm directly writing this one because 15 comes down. Clear? Even in next one, b is minus 1 over 6. So here the sign becomes minus and 6 comes down. So directly, I prefer if you can write it. Rather than putting minus 1 over 6 and taking 6 down, if you can directly write it, it's really good. A plus c, what is c? 1 over 10. So 10 comes down 1 over 10 times x minus 3. So if you can write your final answer in this way directly, that's really good. But always keep in mind, do your simplification according to your level. Not my level or not your friend's level, according to your level. Hands up who got this answer. Question number 14. 2 over 15 minus 1 over 6, 1 over 10. Hands up. Okay. So 17, I'll get the answers from you. So then we don't have to spend time to write it. So 17 is 5x plus 7 over x plus 1, x plus 2, and x minus 3. So here, you have been taken the answer a over x plus 1, b over x plus 2, and c over x minus 3, x plus 1, x plus 2, and x minus 3. Okay. This side, corner side, tell me what is the value of a? What did you get for a? The numerator of x plus 1? 11 over 10. Is that 11 over 10? Okay. So here it is 11 over 10. So 11 over 10, 10 comes down. Okay, this side, what did you get for b? Not sure. Hands up who got 11 over 10? Maybe I have to do that simply. Hands up who got 11 over 10? Wait, I'll simplify. Kai dunne thaniyama. Okay. Okay, let's say multiply by x plus 1. Silence. Thaningan. X minus 2. Silence. 5x plus 7 is equal to a times x plus 2, x minus 3. B times x plus 1 and x minus 3, and c times x plus 1, x plus 2. Clear? Okay, so when you put x equals minus 1, x equals minus 1, here it's minus 5 plus 7 is equal to a into minus 1 plus 2 and minus 1 minus 3. Don't consider the other two, it becomes 0. So it's 2 is equal to a into 1 into minus 4. So when you get 2, so I get minus 2a is, so like simply when you simplify, I get a is equal to minus this. As I got a equals minus oh, good. A equals minus half. Okay, so when you put x equals minus 2, it's 5 into minus 2 plus 7 is equal to this becomes 0, this becomes 0, b times minus 2 plus 1 and minus 2 minus 3. Minus 10 plus 7 is equal to b into minus 1 into minus 5. So here it's minus 3 b into 5. So I get b is equal to minus 3 over 5. What's c? Oh, that's 11 over 10. Okay. C is 11 over 10. X equals 3. It's 22. 4 into 5. 2 cancel off 11 over 10. Okay. So C is 11 over 10. So you can write the final answer. So what are your partial fractions? X minus 1 are divided by 2. Sorry, 5x plus 7. 5x plus 7 divided by x plus 1, x plus 2, x minus 3. Oh, now I can directly write the answer. What is A? A is minus half. So minus 1 over 2 times x plus 1, 2 comes down. And B is minus 3 over 5 times x plus 2. And C times, C is 11, 10 comes down over 10, x minus 3. Okay. Hands up who got question number 17 correct. Okay. Now this is the thing. Okay. Now let's say I'm getting these A, B, C values because the numerator of x plus 1 is A, x plus 2 is B, and x minus 3 is C. Now let's say someone has changed those. Like you are writing x minus 3 first and you have taken the numerator. Now let's say you are writing x minus 3 first and taking the numerator A. Now tell me whether this A will be minus half. It's the same. No, it's not the same because you have changed this one. So then your A will be this 11 over 10. So always like keep in mind, according to the constant that we use, these ABC terms can change. Okay, like according to what we have considered as the numerator, the ABC terms can change, but the final answer should be the same. Okay, the final answer should be the same. Clear? Okay, so let's have a break. They have kept the papers, the marked papers of last term test. The main paper, the girls' papers are here, boys' papers are outside. So what? Now listen, wait. What I want you to do is, okay, silence. Okay, silence. So I won't be giving any medals today because I have silence. No. Okay, I have uploaded the marking scheme in the group. What I want you to do is when you go home, go through your paper and go through the marking scheme, and if there's any things that should be amended, that needed to be corrected, we have put a WhatsApp number. You can send those to that WhatsApp number. There's a change of the marks. Get them changed. Especially students who have scored more than 75. If there are a change in your mark, make sure that you send it to that particular WhatsApp number and then get the marks amended. And next week I'll be awarding the medals, and we will be doing the paper discussion of this one on Sunday. This week Sunday, I'll put the time in the group. Make sure in Sunday evening we'll be doing the discussion of this paper. Okay, come by 5:30. Okay, silence. Okay, now silence. Now look at question number 19, and what I want you to do is write the first step of splitting into partial fractions. Just write the first step of splitting into partial fractions. Question number 19. Write the first step of splitting into partial fractions. No, silence, silence. Question number silence, silence, silence. Question number 19. I have given some work. Stop talking, do the work. Just write the first step, only the first step. First step of partial fractions. Okay, so what we have in question number 19 is 3x squared, sorry, 3x plus 2. Silence, silence. So we have 3x plus 2 over x squared plus 1 into x minus 1. Okay, now the thing here is I told you like what we have to do first is I need to completely factorize this. No? So here we have x minus 1 and then we have x squared plus 1. But you can't furthermore factorize x squared plus 1. X squared plus 1 why factorize කරන්න බෑ. කරොත් මටත් කියන්න මාත් එක්ක බලන්න. හරි. You can't factorize x squared plus 1. There's no any possibility of factorizing this again. So here you have completely factorized this. So after completely factorizing, what we have to do is we have to write each factor in the denominator in a way that we are having separate denominators. No? So you have to write this x squared plus 1 plus x minus 1. So the only change here when comparing to the things that we have done before is the degree here is 2. I told you the degree is the highest power. Here the degree is 2, a second degree polynomial. Here the degree is, as usual, it's 1. So when the degree is 2, I told you what should be in the numerator. The numerator should be a polynomial where the degree is 1 less than the denominator's degree. So if the degree here is 2, that means the degree should be 1. What is the general polynomial with a degree 1? The first degree general polynomial is ax plus b. So here your numerator should be ax plus b. So that is the only difference here, additional 1. And then here it's normal, a constant I'm putting c. Okay. Okay, so here ax plus b is the first degree general polynomial. The simplification will be the same, but there is a small change. So I'll do this. Multiply by x squared plus 1 and x minus 1. So then you end up with this one. It's 3x plus 2 is equal to ax plus b should be multiplied. This cancel off. X minus 1 will be remaining. C times x squared plus 1. Okay, now look at this. Now look at this. So what can we do here when talking about simple like substituting values? You can substitute x equals 1 because when you substitute x equals 1, this becomes 0. So when you put x equals 1, you get 3 plus 2. 3 plus 2 is equal to, don't have to write this one, it's 0. I write this one, it's 1 plus 1. And you get the answer that C is equal to 5 over 2. So whenever it's possible to substitute an value and get an answer, get that. So that is the first step. Okay. So next one is like if you try to make this factor 0, you know this can't be 0 because we know x squared. Whatever the value that you will be substituting to x squared, it becomes, whatever the value you substitute to x squared, it becomes positive. So when it is positive, this plus 1, this never becomes 0. So there's no any possibility of making this 0. Make a bindu karanda bෑ. Okay, so what I do here is I'm using both substituting values and comparing coefficients. I'm using the both methods. So here I have substituted x equals 1. And now what I do, I'm comparing the coefficient of x squared. I'm comparing the coefficient of x squared. So what I want you to do is, like, the simplest, the easiest way that you can do this, you can expand this, simplify, and take all the x squared terms, x terms, and the constants together. But that is, then you have to write this again. Like you have to write, simplify this for like 3-4 lines. That is not necessary. Just look at this and tell me, from how many places do we get x squared? Tell me, from how many places do we get x squared? In this one, in this expansion, from how many places do we get x squared? In? Tell me. How many places x squared than kiyakin hambenawada? In 2 places. One place is clearly you have this x squared. What is the other one? Is ax into x. So you can see in x squared you are having 2 terms. So what is the coefficient here? Ax squared into x. So here's 1x squared. The coefficient is a. What is the other coefficient? Cx squared. The coefficient is c. So then you can say that it is equal to, there's no any x squared. So when there is no any x squared, I told you the coefficient. No x squared means the coefficient of x squared is in no answers. Like you like freeze. No, when there's no x squared, that means there's no one. So no one is mathematically, we consider no one to be 0. Clear? So here, when there's no x squared, the coefficients would be 0. So here, c becomes, so we have taken the value of 5, z 5 over 2. So a is equal to minus 5 over 2. So that is done. And the next one is, I'm asking you to consider, so I'm doing this in the easiest way. So first we consider the coefficient of x squared, and now I want you to look at this constant. Look at the constant. So if you look at this, you might see that even the constant, there are only 2 places where we get a constant term. One is this b into minus 1, because when we have ax, when you multiply ax, you don't get a constant. When you have ax, when you multiply, you don't get a constant because ax already got x. So here's, we already got ax. So here's, there's no any constant. So only constant here is minus b. What is the other constant is c. So now if you consider the constant, it's minus b plus c. The constant minus b plus c is equal, what is the constant here? It's 2. Okay, now you can say that c is equal to 5 over 2. I'm taking b here and 2 to this side. So I get b, when you simplify this, it's 5 minus 4, it's 1 over 2. So I'm getting the value that b is equal to half. Clear? So I have taken the value c is equal to this, a, this and this. So what did I do? I just substituted one value to take the value of c. Then I compare the coefficients. So you don't have to expand and simplify. When you look at this, it's clear. I get x squared, 1x squared from here. I get 1x squared from here. And the other x squared from here. Okay, then you can write the final answer. What is the final answer is 3x plus 2 over x squared plus 1 times x minus 1 is equal, okay, what is A? A is minus 5 over 2x. Plus B, what is B is half over x squared plus 1 plus C, what is C? C is 5 over 2 over x minus 1. So what happens here? I can take both, like here, what happens is like 2 becomes the common denominator and it comes down. So like both 2's come down. 2 is a common denominator. No? So when you take a common denominator, minus 5x plus 1 divided by 2, and that 2 comes down, and here even 2 comes down. So you can keep the final answer in a much cleaner way, minus 5x plus 1 over 2 times x squared plus 1 plus 5 over 2 times x minus 1. So this is your final answer. What did I do? 2 has been taken down and 2 has been taken down. So no any difference, same thing. The only one is we have to use the both the methods, equating or comparing coefficients and substituting values. Clear? Okay. So it's question number 19. Do question number 19, 20 and 21. To question number 19, 20 and 21. Same drill, same way, you have to do it alone. If there's anything unclear, when I come, ask it from me. If there's anything unclear, you can ask from me. Yeah? Anything, if you think that that is a smaller thing, that is okay, ask from me and clear the doubts. So this is question number 19, 20, 21. So here don't underline this ABC values. I'm just underlining to highlight it, but you don't have to do it. Only underline the final answer. Because ABC are intermediate answers. Don't underline those. It's okay even though you underline, but from here onwards, don't do that. Silence, silence, do it alone. Both questions 20 and 21. No, very can silence, do it alone. Get the final answers. Silence, silence. If I feel bored to simplify, I'll ask someone to come to the board and simplify. You don't get highlighted. I usually do it when we do the same simplification. I get students to come to the board and simplify. Then even I'll be giving the mic so you can talk in a good way. Okay, let's see question number 20. Question number 20, it's 3x squared plus x divided by x minus 2 and x squared plus 3. So here it's a over x minus 2. So since we have used a already, the next one should be bx plus c over x squared plus 3. So why do I use bx plus c? Because the denominator's degree is 2. So the numerator's degree should be 1. The numerator's degree should be 1. So what is the general polynomial with the degree 1 or the first degree? It's ax plus b basically. But since we have used a, I have taken bx plus c. Multiply by this denominator. It's x minus 2 into x squared plus 3. So then I get 3x squared plus x is equal to a times x squared plus 3 bx. Always when you're multiplying an expression, use brackets. Always when you're multiplying an expression, use the brackets. Okay, now substitute x equals to, substitute x equals to, that is the only substitution that we can do such that a factor is 0. Then 3 into 2 squared plus 2 is equal to this is remaining. Don't write this, it becomes 0. So here it's 3 into 4, 12 plus 2, 4 plus 3. Clear? So I'm getting 12 plus 2 is 14 is equal to A into 7, which means A is equal to 2. Okay, I'm just underlining it to highlight it. So when you look at the board, the answer is clear, but you don't have to underline these answers. Only underline the final answer. Then I told you, since the substitution is over, compare the coefficients. You are getting x squared from two places. One is this, and the other one is bx into x. Okay. Okay, then compare the coefficient x squared. Compare the coefficient x squared. So when you compare x squared, here it's a, and here it's b, and there is x squared in the left hand side, it's 3. So here, previous it was 0, because there was no any x squared, but now we got 3. We know a is equal to 2, or then b is equal to 1. I get b is equal to 1. And then go with the constant. Then go with the constant. So when it is the constant, it's 3a and minus 2c. So look at the constant, what we get from here, it's 3a. From here, it's c into minus 2. Minus 2c is equal to the constant. What is the constant here? There's no any constant. There is no any constant means it's 0. So a is 2 is equal to 2 into c, which gives me that c is equal to 3. Okay, I'm getting proper values, integer values. A 2, b is equal to 1, and c is equal to 3. So you can write the partial fractions in this way. 3x squared plus x over x minus 2 x squared plus 3. Okay, this is equal to what is a? A is equal to 2 over x minus 2. And b is equal to 1. So it's x. C is equal to 3x plus 3 over x squared plus 3. Clear? So I'm getting the numerator x plus 3 and the denominator is x squared plus 3. Hands up who got question number 20. Correct? 2, 1 and 3. Good. Okay, then let's see question number 21. 4x plus 5. Question number 21. 4x plus 5 over x minus 1, x squared minus x plus 2. Silence. Okay, same drill. Here it's a over x minus 1. So here it's x squared minus x plus 2. So degree is 2. Put a first degree polynomial, ideally ax plus b, but since we have used a, it's bx plus c. Same thing, because x squared plus minus x plus 2 is second degree polynomial. Sorry. Okay, then multiply by x minus 1, x squared minus x plus 2. What do I get? Is 4x plus 5. A times x squared minus x plus 2 bx plus c times x minus 1. Okay, clear. So substitute one value. So 1 is possible. Put x equals 1. If I put x equals 1, then it's 4 plus 5 is equal to, don't write that, 1 square minus 1 plus 2. That is 0. No? So 9 is equal to 1. Okay. A into 2. So I get A is equal to 9 over. This is good. Okay. So after getting A, then it is the same drill. Consider the x squared. So how many places are there? We get x squared from here. and bx into x. So when you consider x squared, it's this and it is this. So here the coefficient is a and here the coefficient is b. A plus b is equal, look at the left hand side, there's no any x squared, which means the coefficient is 0. No any x squared, which means the coefficient is 0. B is equal to minus 902. Consider the constant. Okay, consider the constant. Look at the places that we get a constant. It's a into 2 and c into minus 1. So we get a constant with a into 2 and c into minus 1. So it's 2a minus c is equal, what is the constant here? It's 5. 2a is 4 into 2a, yeah. Minus c, I'm getting c not easy. C is 4, you get in proper value, okay. So I'm getting a proper value that c is equal to 4. Yes, c is equal. So when c becomes 4, it's C4. No, correct, you got these values. Hands up who got 9 over 2 minus 9 over 2 and c equals 4. Okay, so when you put it here, look at this. It's 4x plus 5 over x minus 1. Look at this. X squared minus x plus 2. Listen. So what is A? You can either directly write it. For now, I'll just keep it in this way. And now look at this, something interesting. Plus, what is B? B is minus 9 over 2x plus C, and C is 4. So because this is the reason that I gave this. So here, look at this. Look at this, Banu. In this case, you can take 2 down. But in this case, tell me, can you take these 2 down? No, you can't take that 2. Like previously, I did it. Like not in this one, in question number 19. If we have both 2 here and 2 here, then I can take it down. So in this one, before taking 2 down, you have to consider the common denominator first. So here, no offense, you can directly take it down. But here, first you have to consider the common denominator. That's why I told you, when we have both divided by 2 here and divided by 2, you can simply take it down. But here you can't do it. Here, you can't do it, so you have to take a common denominator first and then take it down. So then it is 9 over 2 times x minus 1. It's plus minus 9x plus 8 over 2 times x square minus x plus 2. Clear? So only difference is that when we have this in this way, you have to take 2 as a common denominator and simplify. And there is another way that you can express this one. Make a මෙහෙම තියන්නත් පුළුවන්. Look at this. I'll like pull out a minus. So I'll pull out a minus and then it becomes 9x minus 8. So you can even keep it in this way. Both are okay. I can pull out a minus which becomes minus 9x minus 8. So you can either keep in this way or either keep in this way. Okay, finish your work up to here. Okay, now think of question number 23. Think question number 23. So if I give you time and ask you to think, I need you to do that, nothing else. Question number 23. Okay, so now look at this. What happens here is we have this, no? We have, you look at the board, x squared minus 2x plus 3 over x squared plus x cube plus 1. So what is the first step of splitting into partial fractions is we have to completely factorize the denominator. So in order to factorize this, first you have to identify what is in the denominator. So that is the first thing you have to identify. For example, if this one was in terms of x squared minus 1, then you know what is in the denominator. How can you express the denominator? Talk, Tiny, talk. I told you that story, no? Crease story. I told you, no, I can't repeat it again. I can remember I told you this. Crease, increase, decrease. Okay, so here, tell me what is in the denominator? It's the difference of two squares. Okay, still I didn't hear it properly. Okay. So it's a difference of two squares. So if you can't say the difference of two squares, one can be written as one square. Okay, now you can see it. No. So first we have to identify what is in the denominator. Okay, so here it's a difference of two squares. You can factorize. So when we have x squared plus 1, even though 1 can be written as 1 squared, I know the addition of two squares, there's no any factorization. A squared plus b squared, there's no any factorization. Okay, so even though it's here, in this way you can't write it. But now what we got is x cube plus 1. So 1 can be written as 1 squared. Okay, now tell me, what is the format of the denominator? It's the addition of, addition of two cubes. For that purpose, so that's why I told you, we did this area called basic mathematical concepts, and under that we did few expansions. And if you can remember, we did an expansion for the addition of two cubes. So if you can't remember, just write it. A cube plus B cube can be factorized as A plus B, A squared minus AB plus B squared. A squared minus AB plus B squared. So you can use the same expansion here. So x cube plus 1 cube is equal to x plus 1. X squared minus x into 1 is x plus 1 squared is 1. So here, using the addition of two squares, first you need to factorize the denominator. So what is the denominator? It's x plus 1, x squared minus x plus 1 using the addition of two cubes ID. So if you can't remember, write this towards like the top of the book or bottom of the book, and then do the remaining work. The remaining thing you can do now, you can see it's the same as that one, same format. Remaining part you can do. It's about factorizing this. Okay, do this, complete the work. I won't be simplifying this, so I'll be getting the answers from you. So do it properly, get the final answers. Find the values of A, B, and C. I'll take A over x plus 1, a bx plus c over x squared minus x plus 1. I won't be simplifying this. Tell me the answers. Simplify and get A, B, and C. Okay, simplify. So you're supposed to get A is equal to 2, B is equal to minus 1, and C is equal to 1. Your final partial fractions, x squared minus 2x plus 3 over x plus 1, x squared minus x plus 1 is equal to A is 2 over x plus 1 plus B is minus 1, so minus x plus 1 over x squared minus x plus 1. Clear? So I told you, like in the previous one, you can either keep this in this way, but if you feel to keep this in this way, that's even okay. You can pull out a minus and x minus 1, x squared minus x plus 1. You can either pull out a minus and keep it this way, or even this one is okay. Okay, hands up who got A equals 2. Not A means this. The numerator is 2. And then minus x plus 1. Hands up who got it. Good. Okay, complete the work. Okay, can now listen this 1 minute. Silence. Okay, listen. So regarding the marks that you got, So, like, we need to admit this thing. Like, I saw some students, I only saw the marks of students. So, I can say, like, a majority of students have done comparatively good. And even in this class, I saw something one or two 90s were there, and few 80s were there, and 70 plus was there. And in the single and medium class, there was a girl who got 100 out of 100. I intentionally put a additional part that what I expected a student from UL level won't think, like won't be able to do inside one of the polynomials question, to stop like preventing a student getting of 100. But even she has done it in a way, and it's like a complete paper. I don't know whether how did she manage time, because in her paper I just went through the paper. In two of the polynomial questions, she has done it in two ways, like method one and method two inside the paper. I don't know how she managed the time, and she got 100, and there was a 96, like few 90s were there in the single medium class. So overall, like a majority has done well. But what I normally do is like very rarely, or I talk about the students who score high marks, because I don't have to address them. Whatever they do, they are going to do this. Okay, so if they continue in this way, they are going to they are going to get a good A pass for maths. But what I want you to think about the students who have scored marks, less marks or comparatively less marks. And let's be honest, and maybe this is the lowest marks that you have got for maths. Most of the students, when started from grade 6, this might be the lowest mark that you have got for maths. So what should we do? What should we take? The lesson that we have to take from these papers is, because it's a added advantage before writing your first term test at your school, you will be doing a minimum of 4 or 5 papers. Because like, let's say your O-level results will be coming before, like by next week it will be coming, or before 15th it will come in. For next week is the it's the 15th, so most probably on or before 15th results will be coming. In Sri Lanka, when it is on or before 15th, it is on 15th, because they never try to send it before 15th. So next week, like let's say at the classroom, you might get results. Okay, so there is a probability that that can happen. So after getting this one, so your school will be starting. Let's say your school will be starting silence. Listen. I need you to get this lesson. I need to take the lesson from that mark, not the mark, not only the mark. Let's say I have taken 50 marks, not only that mark. I need you to take this lesson, so that won't happen again. So let's say your school is starting somewhere around August, and August, and then after the first term test, you are having the first term test in August, September, October, somewhere around October, November. Let's assume. So it can't be in November, because November we have in A levels. So it should be somewhere in late October or early December. You will be having your first term test. So before that, we will be doing like 4 or 5 papers. So far we have done 2, but the first one is a thing that we can neglect. Like you don't have to think about that basic mathematical concept. So if you take this as one paper, we will be doing again a polynomial unit test, trigonometry unit test, another main paper too. So you'll be doing like 4 or 5 papers, and you are going to that exam. What I want you to understand is, like slowly I am giving you this practice that O levels is not A levels. Because normally if you have a O level, like if you have a term test in one of your classes, when you are doing O levels, what you normally do, if you have the exam tomorrow, you study today and you go to the exam, you do the paper, still you manage to score more than 80. That happens because I have even done, like I study in a different way. So I'm not going to compare myself, but most of the students I know, like my friends even, what they do, like even in school term test, when the school announces we are having the term test in next week, you start studying by today. So what even happened here is the students who scored less marks is not that the students who didn't understand the lesson. Because for example, now I ask you to hands up, like more than 90% of the class, in the students in the class, raise their hands who have done this correctly. The similar situation was there when we were doing polynomials. But when we were doing polynomial questions in the classroom, you were able to do it. But when it comes to the paper, you couldn't do it, or you couldn't score like the maximum mark from polynomials. So that is the difference between O levels and A levels. In O levels, like if I ask you to take a handbill, and if I give you a ratio problem where your grandfather had a land and 1/5 of this land has been given to someone. Your father got the remaining part out of the land that your father got. Your sister got this much, you got this much. So how much of the entire land, the portion you got, you still can do that, no? You still can solve those problems. If I give you an interest problem, okay, this is the object and this is the interest and all, you still can do that. So why we still can do that is that we need to understand those theories were comparatively easier. Those theories are comparatively easier. But when we are coming to A levels, the main thing is not the number one thing. Okay, I admit number one thing, when someone is teaching, you need to understood that lesson. So that is the main thing. But the second main thing is, even though you solve problems inside the classroom, that doesn't mean when we have a paper, you can write the paper and you can do the questions well. Even though you understood the lesson 100% perfectly, even though you solve every problem inside the classroom, that doesn't mean that when you come to write the paper, you will be able to do all the questions of the paper. Being honest, your paper's mark is directly proportional to the amount of work that you have done at home. So that is the basic logic of A levels. Your mark is directly proportional for the amount of work that you have done at home. So if you have done your homework properly, homework means not that the homework we give weekly base is not a such homework. If you have done work at home properly, that will be directly proportional to your mark. So in A levels, I like understand that fact. I have seen students who are really capable, who have a good talent, and when I just look at the books during the classroom, it's clear that they have understood the lesson perfectly, and they have solved almost every question inside the classroom alone before I'm doing the question in the board. But when it comes to a paper, they struggle to take marks. So that is the reason. So the next main paper will be somewhere around August, most probably mid-August or end August. Let's say end August, okay. End August, I'll tell the date exactly. So we are having somewhere around last week of August. So today I am giving a deadline that we are having the next main paper 2 in end August. So what I want you to do is you have to slowly, gradually start working at home. I'm not expecting you to stay overnight and study. You don't have to do that. එහෙම කරන්න එපා. නිදි මරණ කෙනෙක් ඉන්නවනම් රැලි මලාගෙන වැඩ කරනවා නම් කරන්න එපා. Because your A level is 2027. We are still in 2025. So are you going to stay overnight for 2 years? So you won't be able to like stay overnight for 2 years. So that you can do when you come to the last year. But I need everyone here to gradually, slowly start working at home. Because I know, being honest, more than 80% of this classroom wrote the paper only from the knowledge that they gained inside the classroom. You didn't go home and you didn't practice, no? Before coming to the paper, did you practice and come? Like at least we had the paper on Tuesday. Did you went through all the lessons on Monday? We are having an exam tomorrow. So let's take some polynomials. Maybe you must have done it on Monday. Okay, so I'll just do it. Hands up, be honest, hands up. Students who scored, like who started studying or practicing problems at least 2 weeks before the exam. Because I told that we are having the exam in this day. Okay, so I gave a notice before, I think before 1 month I gave the notice. Okay, hands up students who have done work at home. Like if you have done it, like you don't have to be shy to lift your hand up, because you have done it, you deserve. Okay, hands up the students who have done at least 2 weeks, who have worked 2 weeks before the exam. No one. 1 week before the exam. One is there, 1, 2, few from this side. Okay, hands up who practiced before the exam. At least 1 day before the exam. So you can see even only half means like there are a few students who haven't even practiced before the exam. Okay, so your mark is a reflection of the work that you have done at home. Okay, and then you must be telling me, sir, I work according to the same way for my O levels, but it was okay. So that's why I'm telling you it was okay for O levels, but for your A levels, that's not okay. So that's what I want you to, that's the main factor I need to emphasize. I told you at the beginning, I won't criticize O level at all, because when I was doing O levels, That is the greatest exam I had. Even though the level must be low, but that is the main exam I had. So I never criticize O levels. So what I'm doing here is I'm bringing you to the level of A levels gradually, like from O levels to A levels. So that is what I'm doing. So now I want everyone at least to have a small practice every week before coming to the next exam. If not, you will tell me, sir, I understood the polynomials really well, but then if you don't practice at home, you won't be, mark my word, okay? If you don't practice at home, you won't be able to do at least one polynomial question in the next main paper because you have forgotten the lesson. Because when we talk with 2025 and 26 students, mainly 25 students, when they're coming to me, like especially students who are weak, they come to me and talk. So I'm asking them, I need you to categorize the lessons that we have done the classroom according to three categories. So category number one is the lessons that you understood properly at the classroom, and even now you are you can do those questions. So the first category is that when we were doing the lessons in the classroom, you understood it properly, and even now when you do a paper, you can score marks. Again, make me පාඩම් ටික කරන කාලෙත් පුළුවන් දැන්වත් පුළුවන්. Second category is the lessons that you understood in the classroom, but now you can't remember those lessons. Again, කරන කාලේ පුළුවන් දැන් බෑ. A third category is for some reason you didn't understood the lesson, or maybe because you missed the class, you couldn't learn that lesson, or you haven't done that lesson. So these are the three categories. මේක මොකද්ද කරන කාලේ පුළුවන් දැන්වත් පුළුවන්. කරන කාලේ හොඳට පුළුවන් දැන් මතක නැහැ. Now you can't remember. This one is කරන කාලෙත් බෑ. එහෙම නැත්නම් ඒක කරලා නැහැ. Either you can't, you don't like, you didn't understand it, you didn't understood it at all, or you haven't done it. So when I ask them to put the lessons that we have done to these ones, so normally in average, so this is what happened. There might be like this number of lessons. කරන කාලෙත් පුළුවන් දැන්වත් පුළුවන්. කරන කාලෙත් බෑ නැත්නම් කරපු නැති පාඩම් maximum of 2 lessons here. And the remaining all the ticks are in this category. Okay, so this is the category that we have to worry about. Because this one, you understood very well. කරන කාලේ හොඳට පුළුවන්, but now you can't do it. දැන් වාට බෑ. So this is the category. So imagine you are getting questions from an area that you used to know. Then you will be looking at that question and you will be like regretting. I used to be a clever student. I used to do these lessons. These were like simple for me back then, but now I can't remember. So that's what happened if you don't practice. Okay. So like this paper, that is okay. If this is the first one that you have understanding, you got understanding how to do a A-level paper. For this one, I'll give you a chance, like showing the paper to your parents is up to you. Okay, I won't monitor it, or I won't monitor it at all. So showing your paper to your parents is up to you. You have that freedom. But make sure the next main paper, showing your marks to your parents, is up to me. Okay, so I'm giving this, take this as a warning. This one you have the freedom, like, no, sir, I don't want to make my parents, anyways, my results will be coming next week. No, so I don't want to give 2 heart attacks in the same week. So let the paper be in this way. I'll make sure I'll score a good one in the next exam, but make sure next one, I'll be informing the marks because I am responsible for your result, okay? I'm 20% responsible for whatever the result you get. So I need to make sure that 20% will be in a maximum 20%. Like anyways, like remaining 80% belongs to you, but I'll be responsible for 20%. So I'll be monitoring that, okay? And the other thing is, like, because we talked about these results and all, next week when results come, most of the students will take good results. I admit 9 A's, 8 A's, 7 A's, 6 B's, 6 A's. What I believe is results are comparative. Okay, results are, for one person, a result will be really good. For another person, the same result will be a low result. Because when students come to tell me results, I have seen students who even tell, so I got 3 A's in a very low key tone because they were expecting a higher rank. And then when they couldn't get that rank, they got 3 A passes, but still they are telling that in a low key tone. And meanwhile, I have seen students who have taken 3 C passes and even coming to me and telling that is like the biggest achievement that they have done. So that's why I'm telling you, your result is don't compare your result. For one student, 9 A's will be a normal thing, but for another student, 9 A's will be a huge thing. For one person, 6 A's may be a less result, but for another one, 6 A's will be a really good result. So don't compare results. But if you are having a problem, like if you are getting a really low result, and if you are having a doubt about continuing in maths, my advice is before stopping the class, just come to the class next week and talk to me and then go, then let's see what you can do. That can happen. You are expecting and you are getting a really low result. And you won't be able to continue maths, so your school is not allowing you to continue maths from that result. So if you're having a similar scenario, before stopping the class, just come next week, come to the class and talk to me. Then let's see what we can do. Okay, so keep that in mind. Okay, now I want you to do this. Take a handbill or a rough paper and write the first step of question number 25. Take a handbill or a rough paper. Silence, silence, silence. And write the first step of question number 25. Silence, 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 silence. Cutting නෙමෙයි ලියන්නේ. Question number 25. Write the first step. Silence, silence. In a rough paper or a handbill, write the first step of question number 25. Hey, silence, stop this noise. Write independently. Or even use a pencil and write in the same page or last page in the book anyway. Okay. So normally when I ask the students to write this, I have noticed they are writing this in 3 main ways. 3 different ways. One is they consider, okay, I have completely factorized this. And then they are writing a over x minus 2 and x plus 1 squared. And since the degree here is 3, since the degree here is, 2, because we have a square here. No? So when the degree is 2, the numerator, they consider the numerator to be bx plus c. So this is one way that I have seen students write this. Second way is they write the same one, but they expand this factor in the denominator x squared plus 2x plus 1. And then they are writing that factor x squared plus 2x plus 1. Same thing, bx plus c. Okay, so I asked you to write it, but now stop writing. Now don't write. You don't write all these. Wait. So the other way is that I have noticed they write this factor x plus 1 squared as x plus 1 x plus 1, and then they write the partial fractions in this way. So these are the 3 methods that I have noticed students are writing this. Okay, hands up who wrote this first one. Okay, the second one. Third one. Okay, so majority have written in this one. So I'll tell one thing. According to the basic rule, this is correct, this is wrong, and this is wrong. Okay, so what do I mean by the basic rule is first we have to completely factorize this, and then I'm putting each factor, and then the degree here is 2, so the numerator should be 1 degree less. No? So according to the basic one, this is correct. But the basic rule is we have to completely factorize this. No? So when I ask you to factorize this, do you call this as a factorization? X square plus 2x plus 1? No, it's not a factorization. No. So if I ask you, like consider this polynomial, if I ask you to factorize this, tell me, will you keep this one as the final answer? No, you keep this in this format. So this is wrong. So this, like, when I'm asking you to completely factorize it, expand in this is wrong. So that's the error here. So the second one, so this is wrong. So why did you expand it? It's not a complete factorization. Okay. Okay, now the most important thing is now if I consider this one, so here it's x plus 1 squared, and I have written it as x plus 1, and I have written it this way. Most of the students have considered this one. I told you this is wrong. Now what I want you to do is, look at this last one, and I'll give you like 30 seconds, and I need you to figure out the error in this expression. So that's what I want. I'll give you like 30 seconds. I need you to figure out, no talk at all. I need you to figure out what is the error of this splitting that we have done. What is the error of this decomposition that we have done? I'll give you 30 seconds. Just think. Okay, hands up who can give me an answer. What is the error of this last one? 1, 2. Okay. The reason. Okay. So even those two answers are correct, but like mathematically those are correct, but what I expected is what the answer that she gave. Now these two are equal. These two sides are equal. No? Okay, now tell me, if you take the common denominator of this one, what is the common denominator? If you take the common denominator here, what is the common denominator? Is it x minus 2, x plus 1, x plus 1? Do you take this twice? No, we only take this once, no? So if you take the common denominator here, what is the common denominator? X minus 2, talk, x minus 2 and x plus 1. So if you take the common denominator here, it's x minus 2 and x plus 1. But what is the denominator we got? It's x plus 1 squared. So if you split this in this way, you won't get x plus 1 squared. So that is the error here. The error here is you don't get the same denominator. Okay, so that is the error here. This one I told you the error. So this is mathematically correct. But there's another problem. If you can remember, in the definition of partial fractions, I told you, you have to keep it in the simplest format. Okay, so you have to keep this in the simplest format. Every partial fraction you have to keep in the simplest format. Okay, so this is the only error here is this is not a simplest format. This is not a simplest format. So what is the special case here? Because we are having this x plus 1 squared term. So this is the only difference from the questions that we have done before. And this one is this x plus 1 squared term. If not, it is a normal one. Okay. So when it is, when we are having a expression like x plus 1 squared, we call it as a recurring factor. Recurring means we are getting it again and again. So x plus 1 squared, x minus 2 cube, these are recurring factors. You get them again and again. Simply a plus b to the power n is a recurring factor. A plus b to the power n is a recurring factor. So here we have to discuss separately when the denominator consists of a recurring factor, how we are going to decompose it, how we are going to split this into partial fractions. So we have to discuss this separately when the denominator consists of recurring factors. Clear? Okay, write in this way, put using a black pen, write note, and in a red pen, using a black pen, write note, and using a red pen, write recurring factors. Recurring factors. Recurring factors. Black pen, note, red pen, recurring factors. Write this. Factors in the form of factors in the form of a plus b to the power n, a plus b to the power n, this one, are known as recurring factors. Are known as recurring factors. Are known as recurring factors. Okay. Then write these examples. X plus 1 squared, x minus 2 cubed, 2x plus 1 to the power 5. Okay, write the topic. So we are still under rational functions, normal rational functions. Write the topic. Write the topic. Rational functions. Rational functions with recurring factors in the denominator. Write the topic. Rational functions with recurring factors in the denominator. In the denominator. In the denominator. Okay. Okay, now listen properly. So this is how we do this. So in the denominator, we are having a recurring factor. No? We are having this x plus 1 squared. So here, how we do this? Okay, now focus. Look at the board, look at the board. Last part. Okay. So this one is normal. You write it as a over x minus 2. No? So that is the normal factor. No? So when we are having this recurring factor of x plus 2, we write both x plus 1 and x plus 1 squared. So when we have x plus 1 squared, we write both x plus 1 and x plus 1 squared. Okay, now tell me, if we have x plus 1 cube, what else should we write? X plus 1, x plus 1 squared, x plus 1 cube. So if it is the fourth power, we have to write first power, square, cube, and fourth power. Understood? Hands up if you understood this one. Okay. Okay, now when it comes to the numerator, so normally when here the degree is 1, so here it should be a 0 degree. So here it's a constant. So I put B. No. In the normal scenario, here the degree is 1, 2. So the numerator should be a first degree polynomial. So AB has been taken. In the normal case, this one should be Cx plus D. No. So in the normal case, this one should be Cx plus D. No. But here, so when we are having recurring factors, there is one speciality. Whatever the degree is in the denominator, in this recurring factor part, whatever the degree is in the denominator, the numerator should be a constant. The numerator should be a constant. So it is only to this recurring factor part. So this is the recurring factor part. You have to write this in this way. And whatever the degree is in the denominator, we have to put a constant as the numerator. And then the simplification is as the normal one. Multiply by x minus 2, x plus 1 squared. And then you get x squared plus x plus 1 is equal to a. X minus 2 cancel off with x plus 1. 1 x plus 1 cancel off with x minus 2 and x plus 1. X plus 1 squared cancel off with x minus 2. So the remaining is the same, but the difference is you have to split this in this way, and whatever you have in the degree of this recurring factor part, the numerator is a constant. Sorry. Okay. Write in this way. Write in this way. When the denominator consists of a recurring factor, when the denominator consists of a recurring factor, breaking down the rational function, into partial fractions is done in the following manner. Is done in the following manner. Okay, then write the example number 25. So when we are having x plus 1 squared, we have to write x plus 1 and x plus 1 squared both. If it is a cube, we have to write 3. Okay, then show that this is the recurring factor part. So this is the recurring factor part. So let's write in this way. Using a red pen, put arrow and write recurring factor part. Okay, under that, so we are having recurring factor part. Under that, put a small dash and write this note in a normal pen. Okay, write it this way. The numerators of this part, should always be a constant, despite of the degree, despite, despite, that means like whatever, the meaning, same meaning, whatever, despite of the degree of the denominator. Haven't heard that word, this one? Whatever here again. Now when you message, don't use that despite, okay? Whatever, okay. Despite. Okay, whatever, not whatever. Despite of the degree of the denominator. So whatever the degree of the denominator is, you don't have to consider it. The numerator should be always a constant. Okay, then do the simplification that you can do. You can do it with me. Okay, let's do it with me. Start work. You can put x equals minus 1. You can put x equals minus 1. So when it is minus 1 squared, minus 1 plus 1 is equal, this becomes 0, this becomes 0, only c, minus 1 minus 2. 1 is equal to c into minus 3. So c is minus 1 over 3. So there's another one you can substitute. Here you got 2. I put x equals 2. I put x equals 2. So when it is x equals 2, it's 2 squared plus 2 plus 1 is equal to 2 plus 1 squared. This becomes 0 and this becomes 0. So it's 4 plus 3, it's 7, is equal to a into 3 squared, which is 9. So 7 is equal to 9a. So a is equal to 7 over 9. A is equal to 7 over 9. Okay, then there's no any value that you can substitute, then the same thing you can consider x squared. Okay, now look at this. You know you get a x squared from here because when you square this, you get x squared. You get x squared from here. And there's another x squared from x into x. So here the x squared coefficient is a, and here the x squared coefficient is b. So when you consider x squared, here the coefficient is a, and here the coefficient is b. So it's a plus b. It's a plus b. Clear? Because when you square this, you get x squared term. It's equal to 1. I know a is 7 over 9, which gives me b is 1 minus 7 over 9. And then what is b? It's 2 over 9. It's 2 over 9. So when it is 2 over 9, then you can write the final answer. You can write the final answer. A is 7 over 9. 9 comes down. B is 2 over 9. 9 still comes down. And C is minus 1 over 3. So minus 3 comes down. X plus 1 squared. So you can decompose this rational function into partial fractions in this way. Same thing, you don't have to copy paste the board. Okay, x equals minus 1, x equals 2, and then I have considered x squared. Okay, do this in 2 minutes. Do the next question, question number 26. Do question number 26. Only 2 minutes. Do it quickly. Silence and do it. Next one. We did 25, 26. Silence, silence. Something. Next one, 26. Okay, continue to work. 26. So it's a over x plus 3, and here we have to write x minus 1 and x minus 1 squared both. So here it's b, and see, I told you whatever the degree of the denominator of that part, of that recurring factor part, you have to put a constant to the numerator. Okay, you have to put a constant to the numerator. Okay, same simplification, multiply by x plus 3 and x minus 1 squared. Okay, then you get 2x minus 3 is equal to a times x minus 1 squared. 1 x minus 1 cancel off. So x plus 3 and x minus 1 and x minus 1 squared cancel off. So you can substitute two values, x equals 1 and x equals minus 3. So when you put x equals 1, it's 2 minus 3. So this becomes 0. This becomes 0. Only the corner one will be remaining 1 plus 3. So minus 1 is equal to c into 4, which gives you c is minus 1 over 4. Then you can put x equals minus 3. X equals minus 3. So when you put x equals minus 3, it's 2 into minus 3. And minus 3 is equal, this becomes 0, this is 0. Minus 3 minus 1 squared. Minus 6 minus 3 is equal to minus 4 squared. Minus 9 is equal to a into 16, which gives me a is equal to minus 9 over 16. Clear? Okay, then after substituting those values, you can compare a coefficient. So from here you get 1x squared, and from here you get another x squared. So if you consider the coefficient of x squared, it's a plus b simply is equal, there's no any x squared here. So no any x squared means The coefficient is 0. So then B is equal to minus A. A is minus 9 over 16. So B is plus 9 over 16. Clear? Okay, then you can write the final answer. So what is the partial fraction of 2x minus 3 divided by x plus 3 x minus 1 squared is equal to what is A? A minus 9 over 16 comes down, x plus 3, what is B? A plus 9 over 16 comes down, x minus 1. What is C? Minus 1 over 4. So minus 4 comes down, x minus 1 squared. So I should get the answer minus 9 over 16 plus 9 over 16 and minus 1 over. Hands up who got this answer? Okay, then do homework up to question number 31. I'll be checking this personally next week. So do up to question number 31, okay? පොත දාලා එන්න එපා ගෙදරට කරලා. Okay, you can get ready to go. Okay. Okay, 1 minute. Silent. Okay, so 1 minute, maybe. So I'll be doing the paper discussion on Sunday evening. Listen. Sunday evening, most probably around 8 or like towards the later evening, I'll be doing the paper discussion. And make sure that if you have any amendments to do before next Tuesday, get the marks amended. And the other one, I'll be checking the so I'll be checking these partial fractions homework personally next week. Okay, up to 30. Question number 31, you have to do that. So for the newcomers, normally I talk in the first day, but this week I'll talk to them, to the newcomers next week. So then you will be familiar with me for like 2 weeks. No? So for the newcomers, I'll talk in next week. Okay, so we are done for today. You can go home safe.